Hello students, today we'll be discussing Physics CUET 2024 question paper. Before we start discussing, one suggestion to all of you is that you people must be having thorough knowledge of all the formulas. All the formulas should be by heart, because in all MCQ type questions, your remembrance is very important. If you recollect the formula quickly, you will be able to solve the questions properly. So let's move to the question number 1. Question number 1 is from chapter Atom, and we know that kinetic energy, potential energy, and total energy are related to each other. Now, this question says the kinetic energy of the electron is k units, and we know that kinetic energy and total energy are equal but opposite in sign. So, therefore, the answer should be minus k, or and potential energy is also negative. So, without solving, you can easily move to this. The question is having the answer, which is the first option, correct? Let us move to the second question. The second question is again based on the concept that nuclear density is independent of the mass number. So therefore, whatever is the mass number, density has nothing to do with it. So therefore, the ratio of density will be the same, right? Let's move to the third question. Now, this question is involving photoelectric effect, and we have studied that the current depends on intensity, and intensity, as we know, is inversely proportional to intensity, is inversely proportional to square of the distance, and current is directly proportional to intensity. So therefore, we can say the current and distance have the inverse relation, square graph. So therefore, third is the correct answer, because first and second says the current increases, and fourth states there is linear decrease, which is not there. So therefore, we have third as the correct answer. So let's move to the question number 4. Now, the question number 4 is the charged particle is accelerated. Now, we know the de Broglie lambda is equal to h upon under root 2 mqv naught. So it means the wavelength is having inverse relation with the potential. So if you increase the potential, then we find that the wavelength should decrease, because it cannot become 4 times, it cannot be doubled, it cannot remain unchanged. See, you have to remember the relations and apply them directly. Now, this question, number 5th, is again belonging to the chapter Atom. We all know that we are having the various spectral lines series, Lyman series, Balmer series, Paschen series, right? So all these series are having their characteristics wavelengths, and we know that wavelength of Lyman series is the least. Okay, so keeping this point in mind, right? Keeping this point in mind, and the question says, like, they are supposed to be arranged in the decreasing order. So we find that second option is the correct answer, right? Because the different series has the maximum wavelength. So next, let us move further with the semiconductor chapter. We know doping increase the conductivity, and we are having 2 types of semiconductors, N-type and P-type, on the basis of the element which is doped. So for N-type, we know like group 15 elements should be added. So therefore, the answer should have the arsenic, which belongs to 15th group, and the phosphorus, which belongs to 15th group. So as these two are the options A and C, so we have first option as the correct answer, because it involves the addition of the dopant which produce more electrons. Now, question number 7, beta, it is the one which is related to the topic which you people have not completely studied in your 12th class syllabus. So we are having this as the general graphs for junction diode. We are having different type of junction diodes like photodiode, solar cell, Zener diode, right? So these are the typical characteristics of them. So first, I want all of you to have a small more relation. But I remember this is the diode which is called photodiode light detector. It has reverse bias characteristics, therefore is a fourth quadrant. This is but a solar cell, photodiode in the third quadrant. Solar cell, which is in the fourth quadrant. Now this is your typical junction diode. And this is the one which involves the Zener voltage rapid, that is the Zener diode. So these are the typical characteristics of them. And if we arrange them, so we find that the first us is PN junction. So it's the D1, D is a junction 1. So we have first as the correct answer, right? Because like D is the only, first option is the one which has D as junction diode. Let's move further to the next question. This question is involving the concept of magnetic force acting on the moving charges, or it involves the concept of force on the current carrying conductor. So F is equal to, as we know, IL cross B. We are having this as the R length. Now this is the diameter. So therefore it has 2 RKs and this has the R. So if I say what is the effective length, the effective length will be equal to R of left 2R diameter and R, that makes 4R. So as it makes 4R, so we can simply have the formula for the force. That force is equal to 4BIR, right? And we can apply the Fleming's rule, right? So we find that this is the correct option. Then let's move to question number 9. Now this is the question which is related to your formula for refractive index. Refractive index is equal to sine A plus delta minimum by 2 upon sine A by 2. You are given all the parameters, but A is 60 degree given to you because you are having the equilateral triangle. Then you are given the refractive index mu or n equal to √2, right? So we can simplify and we get this 30 degree as the answer, right? So let's move further with the question number 10. Now this 10th question is the first chapter, like whenever you move to the first class of electrostatic, we have the formula of quantization of the charge. So it is always the quantization of charge which involves the transfer of electrons. So it is the integral multiple of electrons which are transferred. So without moving further or looking left and right, you can simply tick this as the answer. The electrons are transferred. Now let us move to this question. Now this question is involving the very important point, like you have to read this question carefully. It says insulating slab of 4 millimeter thickness is put into the capacitor, right, which is having the gap between the plates as 4 millimeter. So gap is same. So it means we have the formula C medium is equal to Kc vacuum, where K is the dielectric constant of it, right? And capacitance is equal to A epsilon naught by D. Because you are not changing A and epsilon naught, you have capacitance which is inversely with the distance. And the question says the distance has to be increased to 3.2. It means the new distance will be 4 plus 3.2, which is equal to 7.2. And with this distance in the denominator and K as a dielectric constant, we can find the value of dielectric constant. Now, question number 12 says a copper ball is immersed in oil and it is suspended in the region of uniform electric field. So if you just recollect your memory, now this is the copper ball. It has weight acting vertically downward. Now the tension acts upward. To balance it, you have another force acting in the upward direction. So for equilibrium condition, QE plus tension is equal to weight of it. Now weight, as we know, that is equal to mass into acceleration due to gravity. But a mass is volume 4 by 3 pi r cube into density of copper into acceleration due to the gravity. Right? So by simplifying, we can get the result 2 into 10 is power minus 5 coulomb. You can easily find the value of Q, the charge, because you are given electric field and all parameters with you. So let's move to the next question. Question number 13. Now the question number 13 says a metal wire is subjected to a constant potential difference, right? So constant potential difference is applied and temperature is increased. So we know that when temperature is increased, there is increase in the resistance of the metals, right? So as a result, we find that thermal velocity is increased, right? And there is decrease in the drift velocity. So you can go with the fourth option directly. Statement-based question. Now this question is involving series and parallel of resistance. But as we can see, these two resistors are connected in series, and this 4 and 4 will make 8. But in the shortcut in this is when equal resistance are connected in parallel, we find the net resistance half, and when they are connected in series, we add them. So 4 and 4 are in series, so we have 8. But 8 and this 8, they are in parallel. So because they are in parallel, so that will make net resistance equal to 4 ohm. Now this 4, here 4, and these will make resistance 4 plus 4 plus 4, which will be equal to 12 ohm. But again, 12 this and 12 this are in parallel. And I've just told you in parallel, the resistance is reduced to half. So that is 6 ohm. So this 6, and this 6 will give 18 ohm resistance, right? So please try to solve the questions in a minimum time. So just look at the question and you'll be finding these type of questions. The series will add and parallel will reduce a value to half if there are two resistances, right? So we have done this 14th question also. Let us move to 15th question. The 15th question states you are having a cell which is connected to this particular, the cell of this EMF is connected to a resistance of 0.5 ohm and it has internal resistance 0.5. So we know that the value of current is E upon R plus R. Now if we simplify that is 1.1 divided by 0.5 plus 0.5, which will make 1.1 ampere current. Now he says it is connected in series with the identical cell, but there is a change in internal resistance of it, and this internal resistance is required. So I2 is, according to the question, will remain the same, right? So I2 will remain the same, which is 1.1 ampere. Two cells are connected, so therefore EMF will be this. Internal resistance is to be calculated, say R dash. Then 0.5 is the internal resistance of first cell. and 0.5 is the external resistance which is connected, right? So you find R dash, which is equal to 1 ohm, right? To keep the current. So we have fourth option जो है, first option 1 ohm as the correct answer. Let's move to 16th question. Now, this is a typical question of Wheatstone bridge. The question says, you are having four resistance P, Q, R, and S. So these are 3 ohm, 3 ohm, 3 ohm. But this is 4 ohm resistance. He says, now you have to shunt this resistance. Shunt means, in parallel, you have to connect the resistance so that it is a balanced bridge. So we know balanced bridge है बेटा 3 resistance 3 ohm है. तो इसका मतलब 4 ohm के साथ हम कितनी resistance लगाएं कि वो parallel में हो जाए. So we know the state relation that this unknown resistance should be equal to 12 ohm, because when you connect 1 by 4 plus 1 by 12, you get 1 by 3. So you need 3 ohm resistance here. So the answer will be equal to 12 ohm, right? Try to solve questions. Again, I'm saying in a least time. Let's move further. Magnetic moment of a thin bar magnet is M. It is bent in the form of a semicircle. So again, without moving into the physics part of it, semicircle means pi r, which should be equal to the length. So r is equal to L by pi. Right? So you are having this as the concept, right? And he says magnetic moment. You know what is magnetic moment? Magnetic moment is current into area, right? And we also have another relation, magnetic moment, which is equal to pole strength into distance between the poles, right? So we have this as answer M into 2L by pi, right? So what is the correct answer? The answer is the fourth one, right? So we are having two formulas. One, magnetic moment current into area, which is not applicable here. And second is magnetic moment is pole strength into distance between the poles. Now let's move to question number 18. He says ferromagnetic material used in transformers. Transformers are using alternating current, right? So because they are using alternating current, so therefore hysteresis loss should be minimum, and they should have high permeability so that magnetic flux linked is maximum. So we have only the second option as the correct one. We can simplify it. Then you are having question number 19. So this question number 19 is involving the basic concept that EMF is equal to electric field into 2 pi r, and also in induction we know E is equal to area into rate of change of magnetic field. So we equate them, E into 2 pi r is equal to area, that is pi r square. Rate of change is given to x. Magnetic field varies, rate change as x. So we simplify, so we have E equal to Rx by 2. So making this Rx by 2, second option as the correct answer, right? So this involves the concept of electric field with potential and chapter number electromagnetic induction. Now, question number 20th is having the current which is flowing in the transformer. We know is the alternating current which flows into the transformer. So what is the value of EMF induced? That is equal to M into di by dt. Okay, EMF is M into di by dt. Now you are given mutual inductance between them 0.5. Now the value of current is provided. He says the crust value of 1 ampere flows. Right? The crust value of 1 ampere flows. So 1 in the first half, other second half. So what is the change? -1, that is equal to 2. Then the time is 2 into frequency 50. So this answer goes to 100 volt. So we have third option as the correct one, right? Remember, in AC, you are having this as a peak and this as a peak. It is 2 times the current reaches maxima in one cycle. So that is why we have 1 upon 2 into 50. Then let's move to question number 21. Now the question number 21 is involving a lot of relations with the formulas mean. So it's a calculation based question. As we all know, but current I is equal to EMF upon resistance, and that EMF is N into d phi by dt into 1 by resistance, right? So current is 1 by R into number of turns into rate of change of flux. And again, we know this current is also equal to beta rate of change of rate of flow of charge, that is equal to dq by dt, right? So we are having the relation dt going with dt, right? So time is not the factor which is involved here. We can find the value of beta charge, just substitute the values, and we'll be getting the answer as 32 microcoulomb. Then again, this is substitution based formulas. We know that, like we can find magnetic flux, that is equal to mu naught Ni, area is beta pi r square, right? So mu naught Ni, area is pi r square. So you can simplify this, and that is how you will be getting this answer to the question. Now 22 is a typical question of optics. When we cover lower half of convex lens opaque, it means no light will pass through it. So you find that intensity is reduced, right? Intensity is reduced. So this is the point which is required. So therefore, we have third as the correct answer, because A says no change in image. Of course, there is change in image because intensity is reduced. Image is always formed and complete image is formed, because we know that there are number of rays which are intersecting, though we draw 1 or 2 or 3, right? So that is why we are having this as the answer. Then 23rd question is based on YDSC, that is fringe width beta is equal to lambda screen distance upon the slit distance, right? So we'll be having, now we substitute the values here, beta, because you are given everything, the wavelength is given to you 500 nanometer. The screen is 2 meter away, and this is 0.1 into 10 is power -3. Right? So we get answer as 1 centimeter. Fine. So this is the part. 24th question is based on your optical instruments. Magnification of telescope is FO by FE. The focal length of objective is given by 10 meters. So please keep one point in mind. The two units given are different. One is meter and the second is centimeter. So 10 meter by 10 centimeter, right? So this is 10 into 100 by 10. So the magnification comes to 100, right? So magnification 100 we have in this question only. आप चाहो तो छोड़ सकते हो. So this will be your correct answer, right? Otherwise, if you want to solve, you know that the length will be equal to 1000 centimeter plus 10, that is equal to 1010 centimeter, right? 25th question is based on the chapter Bohr, but we are not supposed to put unnecessary efforts because this is direct theory based question. Statements which should be by heart. We know that radius is directly proportional to n square. So therefore, this first option is wrong, right? Velocity is inversely to n. So therefore, this is correct answer. Energy is proportional to 1 by n square. So this is correct. And radius is directly proportional to n square. This is correct. So B, C, D and correct answer. So we are having this as the correct answer. 26, we know that, like a full wave rectifier has double the frequency. So without looking left and right, you just simply took like 100. So the frequency will be 100. Twenty-seventh question is again the question which is very common for 12 CBSE also. The question says, it's a non-uniform electric field. That's very important word, beta. Non-uniform electric field and the dipole is parallel. So when dipole is parallel, so we know that torque is equal to PE sine theta. So beta sine 0 is 0. So it means no torque will act on it. Because it is non-uniform electric field, definitely you will be having the force which is acting on it. So the force is acting, torque is 0. So we have second as the option. Now 28th question is again the result oriented question of Gauss theorem. We all know that in Gauss theorem, if you are having equal and opposite surface charge densities, so you have electric field this area 0, electric field this area sigma by epsilon naught, electric field this area as 0. So it means no force here, and the force is acting on this side. Because he says the charge is placed in these areas. So therefore, we find that but a second is the correct answer. Let us move further with question number 29. The two charges are brought in contact. Again, see, search the golden word. Brought in contact means potential of 1 is equal to potential of 2. And once the potential is same, we have the charge upon capacitance, charge upon capacitance. And we know for spheres, charge is 4 pi epsilon naught R1, charge 4 pi epsilon naught R2, right? So we have the fourth as the correct option, right? Thirtieth question is based on Coulomb's law. So, but we know the formula, hai na? F is equal to K Q1 Q2 by R square. He says the charge on each are doubled. So, but a charge on each are doubled means the new force है वो कितना हो जाएगा K into 2Q1 2Q2 upon say D square. Now, because the forces are same, you are given F is equal to F nu. So it means D should be equal to कितना 2R. क्योंकि अगर हम बड़ा D2R करेंगे तो D square जो है 4R square हो जाएगा and 4 and 4 will get cancelled and we'll be having this relation, right? So the question for the values goes with the option number second. The distance should be doubled. The 31st question says you are having two capacitors which are connected in series and the series combination is connected to V volt source. This is C1, this is C2. But C1 is 2, C2 is 3. Of course, microfarad. So these are their capacitance. And if we just recollect, so we know that potential on 1 will be equal to beta C2V upon C1 plus C2. Hai na? We have done this formula in 12th class. How to find capacitance on one capacitor. So we simplify, that is equal to beta 3 by 5V. And V2 is equal to, on the same ground, C1V upon C1 plus C2. That will make 2 by 5 volt. Now if we simplify, we have V1 by V2 is equal to kitna? 3 by 2. Now, if you proceed further, he says find the ratio of the energies also. So what is beta energy ratio? U1 by U2 will be equal to C1 by C2. Half goes. So V1 by V2 whole square. So beta C1 by C2 is 2 by 3. And this is 3 by 2 ka whole square. So what will be the answer? 3 by 2. Right? So if you move with the case, so we have V1 by V2 is equal to 3 by 2. And energy is also 3 by 2. Now this is 32nd question. I have just given you a very important clue for this. The voltmeter resistance and the resistance down are in parallel. So you have their equivalent resistance is, just told you, the equal resistance will be half. So that will become 100 ohm. Now the 100 ohm which is connected in the circuit and 100 ohm of voltmeter and the resistor across which it is connected. So we get the net resistance can be simplified to 200 volt. Now this question says we are having two resistance 100 ohm and 200 ohm in series with 20 volt battery. So what will be the voltmeter reading? So that will be equal to 20 into 100 divided by 100 plus 100. You can find the value of current and then we'll be getting this answer as, this will be 2000 upon 200, which is equal to 10 volt, right? Then we move to question number 33rd. Again, beta is question based on remembrance. We know the formula of equivalent EMFs. What is E equivalent? That is equal to E1 into R2 plus E2 into R2 divided by R1 plus R2. So that is equal to 4 plus 1. This of course multiplied beta 4 plus 1, which is equal to 5 by 3 volt. And similarly, beta R equivalent in parallel combination of the cells can be connected R1 R2 upon R1 plus R2, that is equal to 2 by 3 ohm. So what is the value of current? That is equal to equivalent EMF divided by equivalent internal resistance and the external resistance, which is given to us 4 by 3. And if we simplify, that answer comes to be 5 by 6, right? So 5 by 6 is the correct answer, right? Let's move further. Now this question, if you read, you will find that this question is based on the concept which you have already studied in 12th also and you have done in 10th class also. When we stretch the wire, we find that resistivity is not affected, right? So resistivity is not affected. That is very important factor. क्योंकि बेटा ये वाली जो नॉलेज है आपकी, ये नॉलेज आपके दो फैक्टर्स को रूल आउट कर देती है, राइट? ये जो नॉलेज है आपको दो फैक्टर्स को रूल आउट कर देती है, पहला और दूसरा। क्योंकि पहला कह रहा है कि रेजिस्टिविटी डबल होगी, दूसरा कह रहा है रेजिस्टिविटी हाफ होगी, तो ये दोनों तो हो ही नहीं सकते, तो इस वजह से आंसर थर्ड या फोर्थ में से होगा। ये पहला पॉइंट हमारे पास आ गया। तो सेकेंड पॉइंट बेटा, वी नो दैट कि व्हेन स्ट्रेच, जब बेटा हम स्ट्रेच करते हैं तो हमारे पास दो रिलेशन जो है वो प्रेजेंट है। एक लेंथ की टर्म में आर प्रोपोर्शनल टू एल स्क्वायर, और जो एरिया की टर्म में अगर हम जो है वो लेके चले तो जो रेजिस्टेंस है इज वेरिंग विद आर की पावर 4। तो बेटा इन दिस क्वेश्चन ही सेज reduce the radius to half the value. So if its radius is reduced to half the value, it means a new resistance will be 16 times. So 16 times resistance will allow me to tick third because resistance is 16 ohm. Rest, if you want to verify that we are not skipping this, we know that the power is equal to V square by R. So we have the power inversely to the resistance. So that is why we are having third as the correct option. Let us move 35th question. The three magnetic materials are listed below: para, di, and ferro. हाँ जी बेटा, 36th question is a typical question of chapter 4, moving charges and magnetism. If we just recollect, we know that force acting per unit length is dependent on the current and also it depends on the distance, right? So regarding the force, it depends on the factors, like it depends on I1, it depends on I2, and of course this length will go on this side. So force depends on I1, I2 and L, making third option as the correct one, right? Because the force is dependent on the length also. The 37th question is based on the concept of series parallel and KVL, Kirchhoff current law. But this is the junction. So in this, the current will be divided. Some current will go this side, some current will go this side. So as resistance is doubled, current will be halved. I hope we all agree with this. Keeping potential same, the potential of A and C will remain the same. So therefore, because potential is same, so we have this relation. The current in the upper arm will be half of the one which is moving in the lower arm. So total is 3 ampere of current, 3 I current. This we can divide it. So above will be having I current which is going, and here will be having 2 I current which is moving. I hope first part is clear. Now we are having these two as a semicircular arc. So magnetic field due to semicircular arc is equal to mu naught I upon 4R. We all know the formula. So we'll be using the concept of direction of magnetic field. So we find that B1, that is due to the upper part, will be equal to mu naught into I upon 4R, right? So this magnetic field will be into the plane, and magnetic field due to the down portion will be equal to mu naught into 2I upon 4R, which is out. So बेटा दो मैग्नेटिक फील्ड इन एंड आउट है, तो इस वजह से हम इसका जो है डिफरेंस जो है निकाल सकते हैं. तो डी मैग्नेटिक फील्ड विच इज डाउन ड्यू टू डाउन कंपोनेंट इज मोर, सो देयरफॉर नेट मैग्नेटिक फील्ड विल बी इक्वल टू कितना, म्यू नॉट आई अपॉन 4R, right? So this is the answer. So we have mu naught I 4R which is moving out of the plane. So that is the answer to this question. Let us move to 38th question. Now this is again based on the remembrance concept. So the torque acting is equal to NIBA sin theta, right? So Hanji beta. So the square loop which is carrying current is placed in the magnetic field. He says find the torque acting on this. So we know the formula, torque is equal to NIBA sin theta. You can simplify, put the value, and we'll be getting the answer, right? Number of turns are not provided. It means it's a one turn question, right? So this will be equal to 1 into current is 10 ampere, magnetic field is 0.2, area is beta 10 is power minus 2 whole square, right? So we'll get the answer 2 into 10 is power minus 4 Newton meter. Now again remembrance based question, current leads. So without looking left and right, current lead by 90 degrees. So it means it is a pure capacitive circuit. Now the 40th question is for the change of flux, mutual inductance and the current accordingly. So but we know what is EMF induced is equal to MdI by dt, right? And we also know E is equal to d phi by dt, है ना? So we have E is equal to MdI by dt, E is equal to d phi by dt. So if you equate these two, we get d phi is equal to MdI. I hope it is clear to everyone. Now you just put the values directly provided, you will be getting 1.5 Henry as the answer. Now you are having a wire. Now this a typical NCERT pattern based question, that is you are having a wire of irregular shape A and circular loop in the magnetic field. Magnetic field is given to us, right? So magnetic field is given to us. What is the direction of magnetic field? So in figure A, the magnetic field is into the plane of paper, and in figure B, the magnetic field is pointing out of the plane of paper, right? The question says the figure A, the irregular shaped wire is converted into circular loop, and in the second case, it is converted into a narrow straight wire. So of course, but in first case, you are finding the changing in areas, and second also the area changes are there. Magnetic field direction is opposite, area change is opposite. So we find using Lenz's law, the current will be anti-clockwise in both the cases. Now this question is based on the dependence of opposition on the frequency. So opposition is independent of frequency, we have resistance. Opposition directly to frequency, we have inductance. Opposition inversely to frequency, that is capacitance. And decreasing and increasing, that is a concept of impedance. So but if we apply all these cases, so we find that the option which is correct comes to be the second one. The A has resistance as the correct answer, right? Again, use a concept of direct application. अगर एक ठीक है तो हम लोग बाकी को उसके अकॉर्डिंगली मूव करेंगे. Then again is a remembrance question. इलेक्ट्रोमैग्नेटिक वेव में एनर्जी डेंसिटी जो है बेटा वो सेम होती है. क्योंकि सेम होती है तो आपके पास एक ही आंसर है, दैट इज 1:1, राइट? So in this paper, we are having two such type of question. एक था, like question number 2 we have done nuclear density, मास पे डिपेंड नहीं कर रही और ऐसी एनर्जी जो है वो सेम है. Let us proceed with question number 44. This is very important question for chapter electromagnetic wave. I suggest you people all, because most of the time we are having a question based for electromagnetic waves, and there's a table given in NCERT. You are supposed to learn that table by heart, but then only you'll be able to solve the various questions which are associated with it. He says you are supposed to arrange the different electromagnetic waves in the decreasing order of the wavelength. So it means you are supposed to keep the maximum wavelength first. So we know that X-ray is the one which is having minimum and radio the maximum. So looking into these 2 points, the third is the correct answer, because radio waves are having the maximum. Now this question is again based on the same beta table electromagnetic wave. We know microwaves are produced in magneton well. So this is for microwaves. Okay, this is for the microwaves. So if you proceed with this, so keeping the point of the sources, you find that second is the correct answer, because microwaves are produced by magneton well and radio waves are produced by LC oscillator, right? X-rays are produced by bombarding the metal with high atomic number with fast moving electrons, and infrared is vibrations. So let's move to question number 46. It is based on the spherical refraction. The question says APB as the curved surface of radius of curvature 10, separating air and transparent medium mu of value 4/3. Point object O is placed in air, right? So on this side you have air, on this side you are having the medium. So we have the formula beta N by V minus 1 by U equal to N minus 1 by R. So we are given all the values. We can say beta 4/3V plus 1/20. This is 4/3 minus 1 divided by radius of curvature minus 10. So we can simplify the value, which comes to be minus 16 centimeter. So minus 16 means on the left of this, right? '47th question, we know beta power is 1 by focal length, and 1 by focal length is n minus 1, 1 by r1 minus 1 by r2. So without looking, left and right, you just combine them, you will be getting first as the correct answer. Now, this is a practical question, beta. The plot you will have done, UV graph, right? UV graph, and this graph for convex lens. For convex lens, V is positive, U is negative. So, U is negative and V is positive for real image. So therefore, this is the correct answer. That's the second quadrant. Then move to 49. That's a question based for the width of central maxima in diffraction pattern. So we know width of central maxima is equal to 2 lambda capital D by small d. So we substitute the values. So we'll be getting the correct answer, right? Just substitute the value and we'll be getting the answer. Then proceeding further, we have the famous Einstein equation, half mv max square, that is maximum kinetic energy of the electron, h nu minus h nu naught. So what a nu is 2 of frequency minus h nu naught, that is equal to h nu naught. That is the answer, right? So it's the maximum kinetic energy of the electron which will be calculated, right? Because radiation of frequency is double the frequency. The first option is incorrect. Electrons will be emitted, and all the emitted electrons will have kinetic energy which will be equal to h nu. So half mv max square is equal to h nu naught. Is the maximum kinetic energy of the electrons, right? So I believe keeping the formulas in mind and relations with bit more fast calculation, you will be able to solve and complete the paper. Thank you.